the Pythagorean theorem applies to a right triangle, and if you add up the squares of the measures of the legs, it equals to the square of the measure of the hypotenuse, right? And we know that if you have A, B, and C as the sides of the triangle, if A and B are the legs of the triangle, then which one is the hypotenuse? It's the one right across from the 90-degree angle, okay? That's the longest side in the right triangle, yes? So A squared plus B squared equals C squared. Now this must be the hypotenuse. You can switch the order of the A and the B, but the side here, that must be the longest side or the hypotenuse, okay? All right, so here we go. Let's prove the Pythagorean theorem using geometric mean, and we're not gonna do a formal two-column proof, okay? We're gonna do an informal one. So this is where the geometric mean really, helps. Okay, so this is a leg, and this is a leg, and this is the hypotenuse. And what's our favorite theorem now? It's the whole over the leg, right? So how do we write that? So it's C over A is equal to what? A over Y. And what if you do it with the other side, with the other leg? Then it's what? It's C over B equals B over X, right? Okay, so now, what do we get here for the geometric mean? It's A squared is equal to CY, and here B squared is equal to CX, okay? Now, what happens if we just add these? What happens if I do A squared plus B squared? Well, if I do A squared plus B squared, how much was A? CY. That was A squared. How much is B squared? CX, right? So A squared plus B squared is equal to, let me factor out the C. What do I get? Y plus X. Okay, so look here. How much is Y plus X? How much is Y plus X? It adds up to C. So this is C. That means A squared plus B squared is equal to C times C, meaning A squared plus B squared is equal to C squared. Isn't that, like, amazing? It's amazing, right? So no matter what the lengths of those sides, it's always going to be that. And now we know that, okay, like with proportions, this theorem here is absolutely true, okay? And if you just work with that theorem, that Pythagorean theorem, it just comes out. Yeah.
The Pythagorean theorem only works with the right triangle?
Yes, and so does this proportion, right? Because for the proportion to work, you have to have a right triangle with an altitude drawn from the 90-degree angle. All right. So let's use the Pythagorean theorem here. We're looking for the hypotenuse in this case. So it's going to be A squared plus B squared equals C squared. 20 squared plus 37.5 squared is X squared. 20 squared is 400 plus 1,406.25 is X squared. So 1,806.25 is X squared. What do we do now? Take a square root of both sides. So X is equal to 42.5. Is it plus or minus? Yes? Just plus, right. Okay, so go ahead and do the next one and find X. All right, so for all those listening at home, this is going to be 6 squared plus x squared is equal to 10 squared. Now, 36 plus x squared is 100. So x squared is 64, meaning x is equal to 8. Okay? For the next one, we have fractions, but that's fine because we love fractions. Which two are the legs here? X and 4 over 7. So x squared plus 4 over 7 squared is equal to 5 over 7 squared, meaning I have x squared plus 16 over 49 is 25 over 49. When we subtract 16 over 49 from both sides, I have that x squared is equal to how much? 9 over 49, and if I take a square root of both sides, then x is 3 over 7. Okay? All right, now, so what did the Pythagorean theorem tell us? The Pythagorean theorem said if you have a right triangle, so you start out with a right triangle, then if you add up the squares of the legs, it must equal the square of the hypotenuse, right? If you add up the square of the legs, it must add to the square of the longest side. Now, we can go backwards. We can also talk about the converse of that. And the converse will say, if you add up the squares of two sides of a triangle, and that's equal to the square of the longest side, then what you have is a right triangle. Okay? And so in the beginning, you don't know if it's a right triangle, so you don't use the term hypotenuse. It's just the two shorter sides and the one longest side. All right? So one more time, if the sum of the squares of the measures of the legs are equal to the measure of the longest side, then the triangle is a right triangle. So mathematically, what does that tell us? Well, if you take a squared and you add it to b squared, and if that's equal to the square of c to c squared, then, so if this is true, then it's a right triangle. Okay? All right. So look at this one. We have a triangle. Now, which one is the longest side here? It's the root 61. And if you don't know off the top of your head, plug it in. You know. Well, but you also know that 6 squared is 36. And this is a 61. That means it's bigger than 6. All right. So now you want to see, so this is the longest side. That means that's your C. Okay? So now here's what we're going to do. We're going to say, is a squared plus b squared the same as c squared? Okay? And we're asking a question now. So 5 squared plus 6 squared, is that the same as the square root of 61 squared? Well, this is 25 plus 36. Is that the same as 61? 61 equals 61. So yes, this is a right triangle. Okay? All right. So go ahead and do the next one. And those at home can do the next one. I'm going to pause for a second. So here we get 36. This does not equal 49. This is how we write it. It's an equal sign with a slash through it. So it's not a right triangle. All right? Now, what are Pythagorean triples? We've sort of touched on this. Pythagorean triples are, a Pythagorean triple is a set of 3 whole numbers okay, that satisfies the Pythagorean theorem. So for example, okay, so it has to be whole numbers. That's the point. For example, 3, 4, 5 is a Pythagorean triple. Why? Because 3 squared, 4 squared equals 5 squared. And the cool thing is that once you know that 3, 4, 5 is a Pythagorean triple, all of its multiples are also Pythagorean triples. So if you take 3, 4, 5 and you multiply it by 2 and you get 6, 8, 10, that's a Pythagorean triple. If you multiply 3, 4, 5 by 3, you know, you get that. Another set is 5, 12, and 13. And it's good to know, especially on like SAT tests or whatever, it's just good to know that, oh, if you have a 5 and a hypotenuse of 13, then the middle number must be a 12. You see what I mean? All right, so let's see if these are Pythagorean triples. Determine whether each set of numbers can be measures of the sides of a right triangle, then state whether they form a Pythagorean triple. All right, so here, which one would qualify as C in this case? 16. So we say, is 8 squared plus 15 squared equal to, question mark, 16 squared? And here we get 64 plus 225. Is that equal to 256? Well, on this side we get 289. On this side we get 256, so they're clearly not equal. Now, we have two questions here. Does it make a right triangle? No. So is it a Pythagorean triple? No. So this is a no and a no. Okay? Two answers, two questions. Yeah. Yeah. But it can be a yes and a no. Okay? All right, so look at this one. Which one would be the Pythagorean, or which one would be C here? Well, you have a root 3, that's smaller than 3, so that's not it. Root 6, is that bigger than 3? No, so 3 over 5 must be your C. Don't just always assume that it's the last one, because sometimes you might be tricked. So we square both of them. Is that equal to the square of 3 over 5? Well, here we get 3 over 25 plus 6 over 25. Is that equal to 9 over 25? What is this? 9 over 25 does equal to 9 over 25. So is this a right triangle?
Yes.
Yes. Are they Pythagorean triples? No, because they're not whole numbers to begin with. Okay? The three numbers that we started with must have been whole numbers in order for them to be Pythagorean triples. No, not Pythagorean triple. Okay? All right. So, what about these? I'm going to let you do these on your own. I'm going to go on to the next page, and then if I have time, I'll come back. Let's go to the next page. Pythagorean inequality theorems. All right, so sometimes when you do a squared plus b squared, it equals c squared, but sometimes it doesn't equal c squared, right? So for example, in this case, c squared was not the same as a squared plus b squared. But now look at c squared. Was it greater than a squared plus b squared or less than? It was less than. Well, guess what? It turns out that when c squared is less than a squared plus b squared, we know something more. We know that not only is it not a right triangle, it's actually an acute triangle. And if c squared was bigger than a squared plus b squared, it would be an obtuse triangle. So in order for us to be able to do that, we write it as, c squared first, then a squared plus b squared. And if c squared is less, then it's acute. If c squared is greater, then it's obtuse. So let's do this one. Let's do this one. This is c. So you say C squared, 9 squared, and I'm going to put a blank here. 9 squared, blank, 3 squared plus 5 squared, 81, blank, 9 plus 25. Here we have 81, and what's 9 plus 25? 34. 81 is greater than 34, so this is obtuse.
Can't you just say like equal question mark and then write?
Yeah, and then like based on your
Sure. Yeah. So let's do that for this one. This is C. So 15 squared, does this equal to 9 squared plus 12 squared? This is 225. Is this equal to 81 plus 144? 225. What about it? What do we get on this side? 225. They're equal. So what kind of triangle is this? Right. Okay. So go ahead and do the other ones. You can do them at home. And this homework is due, when do I see you next? Tomorrow. Right. This is due tomorrow.